Hello guys, how are you? So we are again back with another interesting video of semiconductor devices. Already we make a video of semiconductor devices, which is the link of that video is given into the description. You can check after seeing this video. Hope you like this video also. Let's start this video without wasting our time. This is our second video. You are in FEEE YouTube channel. Let's start. Okay, so formation, first start about formation of PN junction diode. What is formation of PN junction diode? So in this picture you can see that in n-type junction major carriers are electron, where about in p-type junction major carriers are proton. Now some electrons from n-type material will go to p-type, and because of that there will be some empty space, there will be some space into the n-type material which will filled by positive charge, and because of that a depletion region is formed. This depletion region is the main effect for formation of a PN junction diode. Hope it's clear to you. Let's see a animated animation about this. See, some from the N type junction, some negative charge will go to P type, and some in the in the vacant space, positive charge has come and form a depletion region. Negative charge goes to P type and positive charge goes to N type, and a depletion region form, and that depletion region is helped to fuse between P type material and N type material, and because of that a PN junction diode is formed. Clear? Very good. See, this is the space. Okay, wait a minute, again it's come. Let's hope for that. Okay, see, this is the negative charge in one direction and positive charge in other direction. Understand? Let's go to our next topic, next slide. That is, what is diode? Diode is a semiconductor and electronic device which have terminal two opposite charge terminal. Okay, and it's help to current flow in one direction. Clear? Direction of the current will be in one direction. There is no two direction. There is no two in the diode. Current will not flow in two direction. Current flow is only in one direction, and it's given to your screen. You can see that. Now into a diode we have two terminal. Two terminal means end point. In one terminal we have anode, that is positively charged, and another is cathode, that is negatively charged. Now from anode to cathode our current will flow. Because of that a diode will form. Now why it is called diode? Because it's have two opposite charge terminals, opposite terminals. One is positive, one is negative, means anode and cathode. Okay, now understand, one is the most important thing is the cathode is normally marked with a silver band, means in this portion we have a silver band. See, this is the imaginary image created by us, and this is the real diode. It's look like this. Clear? Now next topic, that is working of a diode. Diode will work with two bias, we can say that. One is forward bias, another is reverse bias. In forward bias the voltage, positive potential will flow from P type material, where about negative potential flow from N type material. Okay, because of that the space between P type and N type material started decreasing. The width between P type material and N type material started decreasing, and because of that current flow easily and form a diode from this diode. current flow very easily because the width started decreasing between p and n type, and current flow easily from this forward bias. Clear? I am telling you one more time. In the forward bias, positive potential flow from p type and negative potential flow from n type. Mark it. Next is reverse bias. Reverse bias is just opposite of forward bias. Here negative charge flow from p type region, where about positive charge flow from n type region. Clear? Because of that, width between n type and p type, width between n type and p type started increasing, and current cannot flow easily from it. Clear? Very good. Now let's discuss some different types of diode. Now we have many types of diode, but let's discuss about some of them. First is Zener diode, PN junction diode, tunnel diode, varactor diode, Schottky diode, LED diode, pin diode, Aflancy diode, many are there. But one thing you have to understand, that every diode have their specific or identified symbol. For example, Zener diode have this symbol. If this symbol is there, then we understand it's a Zener diode. Okay. Now PN junction diode, we have PN junction diode also, which have the different symbol. We have LED diode have these types of uh, symbol, where our TVS diode have this symbol, Schottky diode, this symbol is there. Different diode have different symbol. The chart is given here, you can check it. Okay, so these are the some of the examples, some of the types of diode which is given there, and these are the symbols of diodes. The source of this photo will be www.electrotechnology.organization. Okay, very good. Now characteristics of PN junction diode. When diode is, as we already studied, that when the diode is connected to forward bias, negative voltage will flow from N type material and positive flow from P type material if the external voltage is greater. Because of that, the value of potential barrier is approximately 0.7 volt for silicon and 0.3 volt for germanium. Potential barrier will be overcome and current will start flow through the diode very easily. Clear? In the following graph, after that we have a graph. In this graph we can see, in this graph it's given that this is called reverse bias and this is forward bias, where you can see the current flow very easily in the forward bias, where the reverse bias current cannot flow easily, and there is a break point where current will not flow because of minority carriers. Clear? So in forward bias current flow very easily, and in reverse bias current can't flow easily because of positive charge started flowing from N type material, and negative charge started flowing from P type material. Because of that, in PN junction diode, forward bias can flow current very easily, reverse bias can't flow current easily. Clear? Let's talk about transistor, one of the important topic of our today's video. Okay, so what is transistor? This is transistor's photo which is given here. Now transistor is a type of electronic device, okay, which is formed by p type and n type semiconductor. This is formed by a p type and n-type semiconductor. A transistor is a device that controls the passage of current or voltage and serve as a button or gate for electronic signal. Means in the transistor there is its control the flow of current and voltage and serve a button or a gate we can say, or a passage we can say, for signaling the electronic way to the other. Okay, Bipolar junction transistors are made up three region. These are made up of three region. These are called bipolar junction transistor. Okay, and these three are called base, collector, and emitters. Clear? Very good. These are the basic. These are the basic this is called the basic definition of a transistor. Now, various application and uses of transistor. A core use of transistor including switching and application or both as amplification and switching. There is a kind of transistor which produce current flow depending on the amount of light shine among them. Those are known as phototransistor. Means in this kind of transistor, current flow depend upon light. Means if the light is there, then current flow easily. So because of that, because it's depend on light, so these types of transistors are called phototransistor. Clear? Why it's called phototransistor? Because photo means light, and this transistor purely depend on this transistor current is depend on light, so it's called phototransistor. Clear? Very good. Now there are different types of transistors are there. This is the chart of transistor. Okay, so b first one is BJT and next one is FET. What is the full form of BJT? BJT full form is bipolar junction transistor. What is this? Let's read this. It has terminal level base, collector and an emitter. Means this B is called a base, E is a emitter, whereas C is a collector. And a small current at the base terminal can control or switch a much larger current between the collector and emitter terminal. Means there is a current in that B which is very small, not as big, but the current which is into the E and C is controlled by the small current which is present in the B or base. Means collector and emitters current are depend on the base current. Okay, it's called bipolar junction transistor. Okay, very good. Next is there are two types of bipolar junction transistor. One is NPN and another is PNP. Now what is NPN and what is PNP? Let's we discuss further. First see the diagrams of them. This A is NPN diagram and this one is PNP diagram. In PNP diagram we can see that the current is coming from E to base B. Where about in NPN current is coming from base B only. Clear? What is NPN transistor? An NPN transistor is most commonly used bipolar junction transistor and is constructed by sandwiching a p-type semiconductor between two n-type semiconductor, and because of that it's called NPN transistor. Okay, it's have three terminals. Again a collector is there, an emitter is there, and a base is there. The NPN transistor behave like two PN junction diode connected back to back. These back to back PN junction diodes are known as collector base junction and base junction. Now understand it, what is this? Where a N type, again a N type, and in between them a P type is there, and it's just look like a sandwich. Means these are all are just come to closer and make a NPN transistor, because N type and N type is in the two N and one P type is between this. That's why it's called NPN transistor. Now in NPN transistor this behave like a p-type air semiconductor. It's behave like a PN junction diode. It's behave like a two PN junction diode. Why? Because this is one PN junction, this one is again a PN junction. So it's behave like a 2 p-n junction which is connected back to back. Okay, very clear. Next one is PNP transistor. In PNP transistor, one n types material is doped with two p type material. It's a device that is controlled by the current. Both the emitter and collector current were controlled by the small amount of base current. Two crystal diodes are connected back to back in PNP transistor. As we discussed in NPN transistor, that the in between 2n, in between 2n 1p is there. Similarly, in PNP transistor, in between 2p n type material is present, okay, which help the conductor to flow. In this, which help the semiconductor to flow current. In this transistor, emitter and collector, emitters and collectors were controlled by the small amount of current, that is base current. Okay, and they are connected just like a PNP. They are connected like a PNPN semiconductor back to back. Clear? Next is FET. What is FET? One is what is FET? Let's discuss this. As we already see here, there are two types of transistor. One is BJT and one is FET. BJT is already discussed, that is bipolar junction transistor. Two types of bipolar is there, NPN and PNP. Now let's discuss about FET, which is another type of transistor. What is FET? First of all, FET full form is a field effect transistor. It's a type of transistor which is commonly used for weak signals. It's not used for strong signal. For example, amplifier. Okay, amplifier. In amplifier, FET is used. Okay, types of FET. FETs are divided into three types: insulated gate FET, betterly known as MOSFET, junction FET, and metal semiconductor FET. Okay, we one by one discuss these three types of FET, which is three subtypes of FET which is there. Okay, first, so this is given there. There are two types of FETs are there. One is junction FET and another is metal oxide semiconductor FET. Okay, in junction FET we have a depletion mode where we have N channel and P channel. What about in metal oxide semiconductor FET, we have a depletion mode. Similarly, we have a enhancements mode. In depletion mode, we have a N channel, P channel. Similarly, in enhancements mode, we have again a N channel and a P channel. Clear? Very good. See, this is a junction FET. As a FET is a chip occupy very small space as compared to BJT chip, FETs are widely used in IC. Means, what is the full form of IC? It's a circuit, integrated circuits. Okay, FET is used in integrated circuits. FETs are used as a voltage variable resistors in operational amplifier and tone control, etc. For mixer operation on FM and TV receiver and in logic circuit. So FETs are very much used in voltage variable resistance, which is used in amplifier, which help us to see which help us to see or listen the operation which will happening on a TV or a FM. Okay, now logic circuit. FETs are generally used in digital switching circuits. Means in digital switching circuit, FETs are very much used. Okay, very good. Circuit diagram of JFET. You can see one is N channel JFET, another is P channel JFET. Okay, you can see here in N channel JFET above VDS, positive charges flow, where in P channel JFET above VDS, above voltage, negative charges started flowing. Okay. Now let's discuss about MOSFET or IGFET, the insulated gate FET. Okay, IGFET full form is insulated gate FET. It's also called metal oxide semiconductor field effect transistor. This is the full form of metal MOSFET. MOSFET, that is metal oxide semiconductor field effect transistor. It's act like similar to JFET but exhibit an even larger resistive input impedance due to the thin layer of silicon dioxide that is used to insulate the gate from the semiconductor channels. Okay, these are the diagrams. These are the diagram of These are the diagrams of MOSFET, MOSFET or IGFT, you can say that. Okay, very good. Next is circuit diagram of MOSFET or IGFT, which is given here. You can see the load is, let me take this. You can see the load is here, and from here uh, capacitance is there, and it started working. It's a homemade circuit. It's the diagram is taken from a homemade and here the current started flowing from this circuit. Okay, this is the circuit diagram of MOSFET or IGFT. Clear? Next is complementary metal oxide semiconductor, alternatively referred to as real-time clock RTAC, non-volatile RAM NVR or CMOS RAM. CMOS is short for complementary metal oxide semiconductor. CMOS is an on-board battery powered semiconductor chip inside computer that store information, means it's used in a computer which help to store information in a computer. This information range from the system time and date to the system hardware setting for your computer, means it's refer from the system time when the system is ready for the for the function to the date to system software setting for your computer, means it store all the information of our system. Okay, if it's not there, then we can say that not of us any information of the operation will be there. This is the picture of metal oxide semiconductor. You can see that it's mainly found in non-volatile RAMs or real-time clocks. Clear? Very good. Hope you all like up to here. This is the last topic of our session. Hope you all like that. Now we will back with a new video in the next week. Let's enjoy it. Let's see this video one more time. Hope you all like this. Thank you and have a nice night or day, you can say. Tata.